Howdy guys, welcome to the second part of our number theory enhancement. Yesterday, remember that we used the Euclidean algorithm to find the greatest common divisor of two numbers, right? And so to use the Euclidean algorithm, we started with two integers a and b such that a was greater than or equal to b and b is greater than 0. So those were just our specifications to use, our requirements to use the Euclidean algorithm. So this is an interesting theorem. Some of you may be aware of it. I didn't know about it until I was a junior in college. Remember, number theory is one of these things that a lot of schools don't teach at the elementary and high school level because there's no dollar sign attributed to it. I think that our standards that we teach are career and college ready standards, right? I think that's kind of a shame. There are many studies that show that when kids are introduced early and often to, quote, interesting math, right, stuff like this, that they become more proficient at math and they enjoy it more. So, this theorem just states that if you find the greatest common divisor of two numbers and multiply it by the least common multiple of those numbers, that is equal to the product of those numbers. So this is a surprising theory to me. When I learned it, some people are kind of blown away by it, and some of them are kind of blasé about it, and they say, well, yeah, that's obvious. Wherever you are, it's an interesting theorem. If we divide each side by the greatest common divisor of a, b, then we know that the least common multiple of two numbers is equal to a times b divided by the greatest common divisor of those two numbers. So a simple example, right, to show you how this works. The least common multiple of 36 and 24. And the way you usually do this in your elementary years when you see this is you just start and you see, is 24 a factor of 36? Does 24 divide 36, right? Because then it would be a multiple. Clearly this one doesn't. 24 does not divide 36. So then what you do is you take the biggest one and you multiply it by 2. And so 36 times 2 is 72, and then you check, does 24 divide 72? If it doesn't, then you do 36 times 3, and then you divide by 24, and you find if that works, right? And in this case, you can see that 24 does divide 72, so the least common multiple of 36 and 24 is 72. 24 goes into it 3 times, right? And you can subtract 3 24s from 72. But, you know, when you ask Wolfram Alpha, or you ask GeoGebra, or you ask some computer software to find the greatest common divisor, most of the programs that I'm familiar with do use the Euclidean algorithm, right? They just kind of start subtracting things away and reducing and reducing and reducing to find the greatest common divisor, and then they'll use this formula, right? So it's a very easy way to do it. When you get to really, really big numbers, like the nest example, this is actually a little quicker than trying to multiply things together and stuff. So, how do we do this with here? So, with these two problems yesterday, we found the greatest common divisor first. So, we said that the greatest common divisor of two numbers is equal to whatever the greatest common divisor of the smallest number is and the remainder upon division of 36 by 24. So let's do that. 36 divided by 24. 24 goes in one time, and when we subtract 124, we get 12. So we have a remainder of 12. So that tells us that the greatest common divisor of 36 and 24 is equal to the greatest common divisor of 24 and 12. The Euclidean algorithm just tells us to repeat that process until we get a remainder of 0, and the last non-zero remainder is the greatest common divisor of our original number. So here we are, 24 divided by 12. Oh, it goes in twice, and guess what? There is no remainder. So that means that the greatest common divisor of the two numbers is our last non-zero remainder, which was 12. Okay, now I'm going to apply this equation, this formula right here. The least common multiple of 36 and 24 is going to be 36 times 24 divided by the least common, divided by the greatest common divisor of those two. So you could go to your calculator at that point, but I would like you to not do that and say, oh, look, 12 divided by 12 is 1, 24 divided by 12 is 2, and 36 divided by 2 is 72. Or 36 times 2, is 72. Okay? So let's do it with a much bigger number. We'll use our calculator because nobody wants to do that much mental math in the morning. Not me anyways. Okay, so the least common multiple of 12,378 and 3,054. Let's just start applying the Euclidean algorithm and say whatever the greatest common divisor of 12, 3, 7, 8, and 3054 is, it is equal to also the greatest common divisor of this and whatever remainder we get when we divide this guy by this guy. So let's go ahead and do that. 12, 3, 7, 8 divided by 3054, and I'm going to my calculator, and 1, 2, 3, 7, 8 divided by 3054, and I get 4.053 blah blah blah. So I know it goes in 4 times, and there's a little left over. So I'm going to take 12, 3, 7, 8 on my computer here, and I am going to subtract 3054 times 4, right? That's what we do when we multiply this. We're subtracting 4 3054s. So I'm doing that with my computer, and when I do that I get 162. So the remainder is 162, and by the Euclidean algorithm we're going to say as our next step that this is equal to the greatest common divisor of 3054 and 162. Okay, so we do the same thing again. 3,054 divided by 162. How many times does it go in? 3054 divided by 162. It goes in 18 times, and there's some left over. How much left over? Let's find out. 3054 minus 18, 162s. 138 is the remainder. And so we have the greatest common divisor of 162 and 138. And we do it again. 162 divided by 138. Clearly that goes in 1 time, and how much is left over when we divide that? That's 24, huh? 24 is the remainder. And then we come back again. So I'm going to go back down here, and I'll start back, and I'll say the greatest common divisor of 12,378 and 3,054. Remember, a lot of you guys, I appreciate you about this, but don't say 12,378 or 12,378 or 12,370 and 8. Do not use the word and unless there's a decimal point there, right? And is for our fractional parts. Okay, so here we are. We are to the point where we're going to find the greatest common divisor of 138 and 24. Okay, so here I am again. I'm going to divide 138 by 24. If you're feeling up on your math, you can try to do it in your head. We don't have to be really, really good at mental math, though. 138 divided by 24, 5.75. So it goes in 5 times, and there's some left over. So I'm going to subtract 5 24s from 138. And I get 18. Now we're getting somewhere, huh? Okay? So I can go to the greatest common divisor of 24, 18. Okay? So we divide 24 by 18. It goes in once, and there is 6 left over. So we are going to go to the greatest common divisor of 18 and 6. We divide 18 by 6, it goes in 3 times, and oh, lo and behold, we have a remainder of 0. So the last non-zero remainder is the greatest common divisor. Okay? Wow, how many steps did that take? 1, 2, 3, 4, 5, 6. So back in the day, I don't know who proved it. Somebody proved that the number of steps that this can take will be at most twice the digits of the biggest number. So that's interesting. So this one at most would take 10 steps, right? It took less. Okay, I'm going to erase this part just so I can go now. The least common multiple is what we were after. We were after the least common multiple of 12,378 and 3,054. And I'll go back to the formula. We multiply the two numbers together that we're looking at. 12,378 times 3054 divided by the greatest common divisor of those two numbers, which is 6. And I go back to my calculator. 12,378 times 3054 divided by 6. 6,300,402. That is the least common multiple. So that's not how many multiples of this do you need to get to there? Let's find out. I'm going to divide that by 12,378. 509, right? So the old way of doing this, take this guy, multiply it. Does this divide it? No. And then you multiply this by 2. You divide by here. Nope, doesn't divide it. You take this and multiply it by 3. Try to divide by it. Nope, doesn't divide it. It would have taken you to the 509th time. Crazy, huh? This is a much, much quicker way to do that. So, pretty interesting. I will give you a few problems that ask you to find the least common multiple of two numbers using the Euclidean algorithm to find the greatest common divisor. I'm getting this stuff right out of this book called Elementary Number Theory. This was my textbook my 3rd year of college, right? My 3rd year of math college, I should say, actually, being a math major. So, you're doing some really cool math. Keep it up. I'm glad you joined us. Love you guys.